So here we have a very practical word problem. So true story, I used to actually build things out of wood when I was a teenager. And something I used to build was skateboard ramps. And this is a very practical problem. I actually did something like this. I actually used trigonometry when building things. And the story goes like this. A skateboarder wants to construct a 2-foot high launch ramp with a 25-degree angle of inclination. How long should the sheet of plywood be to cover the surface of the ramp? So I don't know if you know anything about skateboard ramps, but we'll do an isometric drawing of one. So this is a launch ramp. So you have these kind of right triangles. Along the bottom you have like some 2x4s. You're gonna have a lot more than that. These are 2x4s along the bottom, keeping this kind of, these are actually sheets of plywood right here. These blue ones are going to be sheets of plywood. And then you're going to have these red pieces of plywood which form the skeleton for your surface to go on top. So you got these red pieces of 2x4. And then you're going to lay your surface over the red 2x4. So you're going to put a sheet of plywood down like this. That's going to be your surface that you're going to ride on. So if you look at a side view, you basically got a right triangle. And your plywood is going to be on top of that. So, what's the idea? We have, it's a 2-foot high launch ramp. So basically the idea is you have a skateboarder on a skateboard, and he's going to ride up the ramp, and he's going to launch off of the ramp, right? He's going to launch off of it. So it's 2 feet high, and the angle of inclination is 25 degrees. So what are we trying to figure out? We're trying to figure out how long does this plywood piece have to be? What is the length here? I'm going to try to find L. What is the length of my plywood? So how long am I going to have to cut that piece of plywood? So plywood pieces are usually what? I think 4 feet wide by 8 feet long. So normally the plywood piece would be 8 feet long. And we have to cut it somewhere. We have to cut it. So this piece right here, this black shaded piece is going to fit on top here like that. So how long does that have to be? That's the question. Well, which of the trig functions can we use? Well, we have relative to 25 degrees. We have an opposite side, which is a height of 2, and hypotenuse, which is L. So we can use the famous sine function, right? We got the sine of 25 degrees is the opposite, 2 over the hypotenuse L. So I got this equation. I want to solve it. So to solve this, I can sort of do cross multiplication. I can bring the L up here and the sine of 25 down here. So I'm going to get that L is equal to 2 over the sine of 25 degrees. So L is, let's see, 2 divided by the sine of 25. We have about 4.73 feet. So that's what L is going to be. It's going to be 4.73 feet long, that piece of plywood there. Yeah. So that 8-foot piece of plywood, I'm going to have to cut it at 4.73. And then I'll have this like extra piece of plywood, right? Here on the end in red, that'll be like my extra plywood. I can use that piece of scrap for maybe building something else. All right, so there is a problem. Let's do another problem. What was that number? That was number 3. No, that was number 4, number 5. So we got a 20-foot ladder. leaning against a building makes a 75-degree angle with the ground. Period. How far up the building does the ladder touch? How far up the ladder does... I'm sorry, how far up the building? I got that wrong. Does the ladder touch? Okay, so you have a building. And you have a ladder. So there's my ladder leaning against the building. And it has a 75-degree angle with the ground. So here it's 75 degrees. Of course, there's a right angle here in the sort of bottom left corner. What do we know? This is 20 feet. The ladder's length is 20 feet. So we want to find how high, or how far up the building does the ladder touch. So what is this height here? So, what trig function can I use here? Well, I have an opposite. So across from 75, that's the opposite. And I have a hypotenuse. So I can use the sine again, right? I got the sine of 75 equals h over 20. So to solve for h, just when I'm looking for h, I'm going to just kind of cross multiply, bring the 20 up here. I'm going to have 20 sine of 75 equals h. So I'm going to plug in my calculator. 20 times sine of 75. Let's see, 20 times sine of 75. So 19.3 roughly, 19.3 feet. Yep, so this is about 19.3, the height. Okay, let's try another. Doing fun word problems. These sometimes get a little tricky. A boat is heading towards the lighthouse. That is 80 feet above sea level. If a man on a boat measures the angle of elevation from his eye level to the top of the lighthouse, to be 12 degrees at 10 feet above sea level, how far is the boat from the lighthouse? How far is the boat from the lighthouse? A lot of writing. Okay, so you got, okay, here's your water. Here's your lighthouse, right? Lighthouse is making light. my lighthouse. And I have a boat. Oh, the lighthouse is 80 feet above sea level, right? And I have a boat here. And a man is in the boat. And as he views at eye level, from eye level to the top of the lighthouse is 12 degrees. 12 degrees. So this is 12 degrees right here, this angle, elevation. Now remember, the man is 10 feet above sea level, his eye level, so this is 10. So this would be 10 right here. So that means this side of the triangle right here, that's going to actually be 70, right? 70, because 80 minus 10 is 70. Not to scale, of course, right? And this is not to scale. So what we want to do, we want to figure out how far is the man on the boat from the lighthouse. So how far is this distance right here, x? So x is basically this side of the triangle right here. So I have 12 degrees is my angle. I have x is the horizontal distance from the lighthouse, and 70 is essentially the eye level to the top of the lighthouse height. So I can use the tangent here, right? I can use the tangent. We got the tangent of 12 degrees equals the opposite, 70, over the adjacent x. So to solve this, I kind of pull the x back here and pull the tangent underneath. So I get x is 70 over tangent of 12 degrees. And let's see, what is that going to be? 70 divided by tangent of 12. It's going to be 329.3 feet. How can I spell it? 329.3 feet approximately. 329.3. That's it. Ooh, my foot is falling asleep. Let's do one more word problem. So, what number was that? Number 6. This is number 7. A 6-foot tall observer standing at the edge of a vertical cliff spots the base of a house in the gorge below at an angle of depression. Sometimes you'll hear this called an angle of depression or an angle of declination. That's another word you'll hear, declination. I'll throw that word in there, declination. Depression and declination refer to the same thing, of 8 degrees. The cliff is 60 meters. 60 feet tall. How far is the house from the base of the cliff? Question. All right, so here's the idea. You're having a cliff, it's supposed to be vertical right here. and you have a gorge. So you actually have two cliffs. So a gorge is like a big deep valley inside of, like between two cliffs. So here you have a 6 foot tall man. He's 6 feet tall. And he's standing on the edge of a cliff. And down in the valley below, there's a house. Now we know the cliff is also 60 feet tall. So in total, from the bottom of the cliff all the way to the man's eye level, that's going to be 66. And the man has an angle of depression or declination of 8 degrees down to the base of the house. So he's looking down this way and he gets an angle of declination. Now what is the angle of declination? That would be 8 degrees from his eye level down towards the house. So we're trying to find out how far is the house from the base of the cliff. So what is the distance from the house to the base of the cliff? That's the x we're looking for. Now, we have this thing called alternate interior angles. So if this is 8 degrees here, then this would have to be 8 degrees down here. I know it's not to scale or anything. The angles don't look too accurate, but yeah, 8 degrees. Now we could use here the tangent function to get it x. So I'm going to do the tangent of 8, so that would be this one right here, this angle. So the tangent of 8 degrees is going to be equal to the opposite, 66, over the adjacent. Opposite over the adjacent. So 66 over x. So to solve that, I'll bring the x up here and the tangent down here. So I'll get that x is equal to 66 over the tangent of 8 degrees. So that means x is going to be about, let's see, calculate that in my calculator. Tangent of 66. No, sorry, 66 divided by 66 divided by the tangent of 8. 469.6 feet. So yeah, the house is 469.6 feet away from the base of the cliff. All right, so that is right triangle trigonometry. It's the basics of it.